discussing about the chapter motion. Before that, we have done one video lesson of the chapter. And before we start today's video class, let's just quickly recap what we have learned in the previous video clip. In the previous video lecture, we have learned about reference point. We have learned about motion and rest. Okay, we have seen that a reference point is a point which is used to describe the position of an object. Okay, and reference point is actually the origin. In case of graph, is the origin, and this origin is very much important. And one more thing is there: when we moved to the right side of the origin, we take the numbers as positive, and when we move to the left side of the origin, we take the numbers to be negative. So in today's class, we'll discuss something more regarding this chapter. So let's get started. Okay, so we will start our class today with the definition of motion. Okay, motion is actually the change in position of a body with respect to time. So if a body is changing its position with respect to time, then that can be termed as motion. However, if the body is not changing its position with respect to time, then it is termed as rest. But again, I have told you in the previous video lecture that rest and motion is relative terms. That means they are relative to each other. That means if one person is motion for another person, that very person might not be in motion for another third person. Okay, he might be at rest. So one example also I have given, like the train example. Okay, so that is the thing, that motion and rest are relative. Now two very important terms, or two very important physical quantities that are needed in order to describe motion, and those are distance and displacement. Okay, so what is distance? Distance is actually the length of the path traveled by a body. Okay, so the actual length, actual path traveled by any body from one position to another position, from one point to another point, that is called distance. Now remember students, whenever we deal with this kind of things, distance, displacement, we first of all decide what is the initial point and what is the final point. Means what is the initial position of the body or the object, and what is the final position of the body or the object. Okay, so initial and final, these two things are very important. Then we have displacement. Now displacement is the length of the shortest path traveled by a body from its initial to final position. That means displacement is always the shortest path. Okay, however distance is the actual path that we move. Now both have the same SI unit. That means distance and displacement both have the same SI unit. Both are expressed in meters. Okay, and now let's just understand distance and displacement in more details. For example, you can see over here there is a number line. There is a body starting in a straight line. That means a body is moving in a straight line from origin O and moves through C and B and reaches A, and then moves back and reaches C through B. Okay, so now we shall see what is the distance and displacement here when the body is moving. Okay, first of all, see, distance travel is 60 plus 35. Now how it is 60 plus 35, we will see here. First of all, the body, from where the body is starting, the body is starting from O. Okay, then it moves through C, B, and then reaches A. So from O to A, what is the distance travel here? 60. Okay, that is why we have written 60 here. Then again when it reaches A, it will move back to C. Okay, so from A to C, what is the distance now? See here, when it is moving back from A to C, see, here the difference between 2 points is taken to be 5 units. That means 5, then 10, 10, 15, then 20. Okay, now if we calculate the distance from A to C, how much it will be? See, from 60 to 55, 5 units. 55 to 50, one more 5 minutes. Like that if you count, so 5 plus 5, then 5, 15, then 20, 25, 30, 35. Okay, so you just count the units from A to C, it will be 35. That means from O to A it has covered 60 kilometers. Then again when it reaches A, it came back to C, right? So from A to C, you just count the units. Okay, from A to C you just count the units, taking 5, 5, then it will be 35. Okay, so 60 plus 35 comes out to be 95. So 95 is the distance that is traveled by the body here. However, what is the displacement? Displacement is only 25 kilometers. How it is possible? Let's say, the body, what is the initial and final position? In displacement, two things are very important: initial and final position. If you just know the initial and final position, it will be that easy for you to find out the displacement. Okay, so what was the initial position here? The body has started from origin O, so that origin is the initial. O is the initial position for us. Okay, then it moves to C, B, then reaches A. Again from A it started its journey, then moves back and then reaches C. Okay, so what is the final position here? C. Okay, that means the body started its journey from O, then it reaches A. Again it moves back from A and then reaches C. So what is the final here? C, right? So what is the difference between the initial and final? That means between O and C, what is the distance here? 25. That means displacement is 25 kilometers. Understood? So in displacement, you just have to see the initial and the final points. You will get the answer that easily. So let's just move ahead. Okay, so here I just want to let you know that how distance and displacement differs from each other. See, a body wants to reach point B from point A, so he can take very many paths. He can go like take a round and go. He can take a curved path also and then reach B. However, if you want to reach B very quickly with a shortcut, or if he wants to take a short path, then he will go in a straight line. Okay, so this straight line which is joining A from B, A to B, that straight line is the displacement, and displacement is always the shortest path between 2 points. Okay, all right. So here's another example where we see the difference between distance and displacement. Suppose this man wants to reach that house. So there are two ways. Either he can travel 4 meters first from the first tree to the second tree, then again from the second tree to the house. That means 4 meters plus 3 meters. So here 4 plus 3 is the distance traveled by the man. However, if he wants to reach his home with a short path, then he can take this straight line. Okay, this straight line is how much? 5 meters. So here one thing we can notice is that displacement is smaller than the distance. Okay, so you should remember this, displacement is smaller than the distance. Alright, so these are the differences between distance and displacement. First of all, distance is the length of the actual path covered by the body irrespective of its direction of motion. Yeah, so whatever actual path we are taking a round or we are taking a curved path, that is the distance. Okay, and distance does not depend on direction. We are unaware of the direction. We are moving towards left or right or east or west. Nothing is mentioned when we talk about distance. Okay, however, displacement is the shortest distance between the initial and final position of an object in a given direction. That means in displacement, two things are important. It is the shortest distance between 2 points, 2 positions, okay, and it also tells us the direction, in which direction the body is moving, whether the body is moving towards east or west or left or right or upward or downward, like that. Okay, but in distance nothing like that is mentioned. Okay, then distance is a scalar quantity, displacement is a vector quantity. Yes, scalar and vector quantities are kind of physical quantities. Now scalar quantities are those quantities which have only magnitude but no direction. Okay, magnitude means the numerical value. If I say you have to travel 2 kilometers towards north, so here 2 kilometers, the numerical value is the magnitude. Okay, and north is the direction. Okay, now if I say you have to travel 2 kilometers, did I mention about the direction? No, just 2 kilometers I said, so that is the distance. Okay, and scalar quantity means it will only depend on the magnitude and no direction will be mentioned. That means distance is a scalar quantity, no direction is mentioned. Okay, but if I say you have to travel 2 kilometers towards north, that means we have the magnitude. What is the magnitude here? 2 kilometers. What is the direction? North. So displacement is a vector quantity. So those quantities which have both magnitude as well as direction, those are called vector, and those who have only magnitude are known as scalar. Okay, then we have distance can never be negative, it is always positive or 0. Yes, distance can be 0. If you are at rest, then distance is 0 if you are not moving. Okay, and distance is always positive. Why? Because remember the origin number line we considered. From that number line we can move either to the right side or to the left side. Okay, when we move to the right side we say that it is positive. When we move to the left side we say that it is negative. So positive and negative tells us direction, and direction is indicated only in displacement, not in distance. Okay, so distance cannot be negative, however displacement can be negative. So you can say that displacement is negative, positive or 0. Displacement can be 0 also, we will see in the next slides. Okay, then we have distance between two given points may be same or different for different path choosing. Yes, distance can be different paths. You can take very many paths to reach one point from another point. Like already I have shown you in the previous slides, you can take a round, you can go like a curve. Okay, but displacement between two given points is always the same. Why? Because it is always the shortest path, always a straight line. Okay, all right. Okay, so this is an example stating how the displacement can be 0. Can a body have 0 displacement? Yes, a body can have this 0 displacement. Let us discover how. Suppose a body is traveling from A to B, B to C, C to D, and suppose the body is again returning from D to A. Okay, so stating how the displacement can be 0. Given points may be same or different for different path choosing. Yes, distance can be different paths. You can take very many paths to reach one point from another point. Like already I have shown you in the previous slides, you can take a round, you can go like a curve. Okay, but displacement between two given points is always the same. Why? Because it is always the shortest path, always a straight line. Okay, all right. Okay, so this is an example stating how the displacement can be 0. Can a body have 0 displacement? Yes, a body can have this 0 displacement. Let us discover how. Suppose a body is traveling from A to B, B to C, C to D, and suppose the body is again returning from D to A. Okay, so suppose the body is traveling from A to D, and from point D it is again traveling to A. So what is the initial point here? A. What is the final point here? Again A. So that means displacement is 0. When the initial and the final points are same, then displacement becomes 0. However, distance, if you say, if a body moves from A to point D, okay, then the total distance will be what? ABCD, okay. However, if the body travels a path ABCD and returns back to point A after taking another path DA, then the total distance traveled by the body will be what? ABCDA. That is the total distance, okay. But however, displacement will be 0. So distance cannot be 0. Okay, so distance cannot be 0, displacement can be 0. Alright, so in this slide, I just want to let you know the difference between vector and scalar quantities. So scalar quantities have magnitude but no direction, vectors have magnitude as well as direction. Okay, examples are given here: distance, speed, mass, energy, density, power, time, temperature, work, length, area, volume, all are scalar. That means they do not have direction. Mass is scalar but weight is vector. Weight has direction, okay. The weight of a body acts towards the center of the earth, right. Force is vector, okay. Force has a direction, in which direction you are applying a force to somebody, okay. Similarly, speed is scalar, velocity is vector. Velocity has direction, speed do not have any direction, okay. So on the left hand side you can see, if I tell you that you have to move 2 meters to the right, that means I am mentioning the displacement. But if I just simply say you that you have to move 8 meters, nothing is mentioned about the direction, then that is simply distance. I hope the difference between scalar and vector is clear to you. Those quantities which have direction are called vector, okay. They have both magnitude and direction. However, scalars only have magnitude, okay. Alright, so this slide again I am putting over here to show you how the displacement of a body can be negative. Now see, in the previous video lecture also I told you that this tree is the reference point for us. That means this tree is the origin. Okay, so we know if we move towards the right hand side from the origin, we take the numbers to be positive, and if we move to the left hand side, then the numbers becomes negative. So the dog is at the right hand side, so his position is +1 meter, and the bird is at the left hand side, so the displacement of the bird is -4 meters. Okay, the displacement of the dog is +1 meters. However, the displacement of the bird is -4 meters. Now we can also say that the dog is in which direction? It is in the right direction, okay. However, the bird is in the left direction, okay. So negative and positive tells us the direction of the body, okay, whether it is in the left direction or whether it is in the right direction or in the left direction. So that's how we can say that displacement is displacement can also be negative, because negative displacement tells us the direction. It tells us that the body is in the left direction, okay. Alright, so this is one numerical that I have solved, and let us solve this together. See, there is a body, and the body is moving in a square of side 10 meters. We have to calculate the distance and displacement in each of the case. Number 1 is from A to B. So just look at the picture here. From A to B, what is the distance traveled? 10 meters. Obviously, what will be the displacement? 10 meters obviously. Initial point is A, final point is B. So difference between these two is 10 meters. Okay. Then next is from A to C. So from reaching A to C, we can take two paths. One is the shortcut, another is a long path. So distance is always greater than displacement. Displacement is always shorter than distance. So what will be the distance here from A to C? See, from A to B we have 10 meters, then B to C we have 10 meters. So 10 plus 10, 20. 20 meters is the distance. Okay. However, displacement is the shortest part. So you just take a straight line, join A and C. So that is the diagonal of this square. So we can find out using Pythagoras theorem. Hypotenuse square is equals to base square plus perpendicular square. Using that theorem, we can find out AC is equals to 10 square plus 10 square. That means 10 root 2 meter. Okay. Then the third one is you have to find the distance and displacement from A, B, C, D, A. So from A to B 10 meters, B to C 10 meters, C to D 10 meters, again D to A 10 meters. That means total distance will be 40. 10 plus 10 plus 10 plus 10. Okay. However, displacement will be what? 0. Why? Because the body was starting at A and it has ended its journey at A itself. So starting and ending point are same. So displacement will be 0. So likewise, you can calculate the distance and displacement. So I hope you have understood whatever I tried to make you understand in this video class. So these are the home assignments that you have to do. Question number 3, you just ignore that. Question number 3 is not for today. You just do question number 1 and question number 2. Okay. And you can just send me your answers in my email ID, which I'll mention in the description box. And you can also find my email ID when you download the PDF sheet from the school website. If you have any doubts, any queries, anything you have not understood, you just really comment me in the comment section box. That's all for today. Thank you.